Okay, we're going to take a look at Venn diagrams and then solving for the intersection of two sets, we'll call it. So we'll read this question. There's a school that has 870 students. The school has 502 students taking, not taken, taking math courses currently, and 410 students taking language courses at the moment. There are 207 students who are not taking any math or language courses. Create a Venn diagram to represent this scenario. So, first off, we kind of have to get an idea of what it is we're trying to represent. Oh, that's not what I wanted to draw. Let's try that again. There we go. Let's draw. I'm going to draw a rectangle here. And the idea of this rectangle is it is going to represent a set. So a set here is the entire school in this case. And we know that the school has 807 students, or 870 students. So this entire rectangle represents 870 students. We also need to represent students taking math. So we have our circle here. Let's try that again. Sorry, my pen's not working so well. There we go. So here's our students represent taking math, and here's our students who are in language. Did it again. That's annoying. I'm gonna pause. Okay, kind of solved that. A little bit of overlap here. We'll fill in the second part here. Ooh, yeah, great. Okay, so our green here is going to be, like we said, our math courses. So we have 502 students taking math. So we'll just say math is equal to 502 at the moment. And language, well, we did with that blue circle there. Here we go, 410 students that are taking language. So we'll say language. There it is, 410. There's also students who are not taking anything. And those are, sorry, not that they're not taking anything, but they're not taking a math or a language course. We can maybe put them in red here. So there's 207 students, no math or language. So I've kind of written them out with words. What we're going to do here is we're going to actually try to build an equation that will solve this for us, because in order to represent this Venn diagram, to put students in math, what we want is in the intersection here, so this is where we talk about that intersection, whereas two sets will intersect each other. These are students who are taking both courses. We need to know this number. That way, in this space that's outside the intersection, we can say all the students who are only taking math. We can say the students who are only taking language. And then we can put the students who are taking both. And then outside of this, and this is not to scale because this number is not quite right, but anything outside of these two circles are students who aren't taking anything. That is a piece of information that we can already put in here. Let me see, can I shrink this and try? Yeah, I can. I'm going to shrink this a little. Okay, be a little more representative of what we got here. So there are 207 students who aren't taking anything. There we go, 207. So they're outside of that. They're not taking math or language, we should say. So I'm going to try setting up, there we go, we're going to try setting up a bit of an equation. We're going to say that school, we'll use the variable s here. So the school, which is all of the students, is equal to, so this is all of the students in the school. We'll say math is equal to all the students taking math, plus all of the students taking language, but that has to subtract all of the students who are taking math and language. And what we're going to do is we're going to just use this intersection. So it looks like this. Think of it like a upside down U or a lowercase n. We're going to subtract the students taking both because we don't want to double count those students. Plus students who are not enrolled, we'll just give that an n here, okay? So not enrolled. So we've given a bunch of variables to represent this. We can start plugging in some of the numbers and we'll see what it is we're trying to solve for. I'm going to just keep writing in black after this point so it's a little easier. Our school is 870 students. Well, I guess I'll substitute with the letters to start, or the colors to start. So 502 are taking math, plus don't forget the other 410 who are taking a language course. But this one, the intersection, that's actually an unknown. So at this point, we're just going to represent that with X. Unknown, we don't quite know. We have to solve that before we can represent this Venn diagram. And students not taking either math or language, well, actually, there's 207 of them. So this actually becomes much more of a like a solving for isolating one variable type of question. So I'm going to take this, and we're going to kind of just isolate for X over here. So in order to do that, I'll rewrite it all in black. 870 is equal to 502 plus 410 minus X plus 207. Sorry, I kind of ran out of room. I'm actually going to move the X to this side of the equation. And because it's a negative, it will become positive over here. So we're going to get X plus 870 is equal to 502. And I can just do this to make more room. There we go. Plus 410 plus 207. Okay. And I'm going to move the 870 over to the other side of the equation here. And that's going to help us isolate for X. So X will now equal 502 plus 410. Sorry, my pen's. Plus 207, subtract 870. Okay? Now we just have to kind of go through that process of adding all these up. I'm going to do that on the top here. So 502 plus 410 plus 207. We'll add them all together. That's a 9, a 1, a 9, 10, 11. So X is equal to 1,119 students. Subtract the 870 here. X is equal to 1,119. Subtract 870. Get back. So we got a 9, borrow. That gives us a 4. Borrow again. Gives us a 2. So at the intersection, okay, at the intersection of students taking both language and math at the same time should be 249. So I'm going to see if I can zoom back in. I can. We're going to try this now. So 249 should be at the intersection of the two. Now, with that being said, we have to figure out how many are just taking math, because that's what we would place in here, and how many are just taking language, so they're not taking both. In order to solve that, we need to get the original number of students taking math, okay? So zoom out again. We can solve that down here. We know that there were 502 students taking math. We're going to take this 249 and we're going to subtract. Okay, so borrow. So it comes to 9. 3, 5, 2. So there should be 253 students who were only taking math, and then another 249 who were taking both math and language. And for students taking language, actually, you know, I'll put this in green just so there's, in terms of a note, this is a little better. There's the 410 students. Well, we also need to subtract that 249 who are taking both. Borrow. Comes 1. X and 1. There are 161 students that were only taking language. So, if we take a look, we have only taking math, 253. Only taking language, 161. Students taking both math and language, 249. And then there's 207 who aren't taking anything. These numbers, to ensure they're right, should add up to the actually total of the school. So the entire set, remember this entire set is supposed to be 870. So let's see if the left side equals the right side. So we should say 870 is equal to students in math, which are 253, plus students in language is 161, students taking nothing, 207, and finally, students taking both math and language is 249. I got some space somewhere? Yeah, over here I got some. Let's do some addition. So, 253 plus 161. And obviously you can use a calculator to do this. I'm just going to add all four together. This makes a 10. That makes another 10. Good, we got the 0, right? There's 20 there. 11, 12, 13 plus 4 is 17. That number is correct. And the 1, 2, 3, 4, 5, 6, 7, 8, 870. So the left side here is equal to the right side. We just confirmed it. 870 is equal to 870. So in order to create this Venn diagram, we needed to create our equation. We set the total number of students in the school equal to the students who are taking math, students who are taking language, subtract the students taking both because we don't want to double count them, plus students who aren't enrolled in anything. And essentially those are all your options. You are either taking just math, just language, so just math, just language, both, or nothing. Those are really the only options you can be if you are enrolled in that school. Once we set out that equation, we plugged in the knowns, and we discovered that our intersection, where the two sets meet each other, that's what we were looking for. We isolated for x over here, did some isolation. We then took that value, subtracted it from the total number of math students so that we knew how many were intersecting, how many were only taking math. We subtracted that number from the total number of language students so that we know how many were taking both and how many were just taking language. We plug them in to represent the Venn diagram. And then finally we add them all up to ensure that we are at the proper number of 870, which we were. It's quite a bit of work there, but we've done it.